So hello Unite and welcome to this talk about going multiplayer, making games that keep cheaters away. In this talk, I'll show you how to repel and deal with cheaters so you can keep your community and in-game economy safe. But first, let me introduce myself. I'm Paola Vela. I'm a senior netcode engineer at Unity and CEO and co-founder of Fatum Games. I've been in the gaming industry for more than 12 years, shipping several single-player and multiplayer titles. And I'm also the author of the book, Going Multiplayer, a complete guide from design to post-release, which inspired part of this talk. So today we're going to talk about cheating. And specifically, we're going to see why do players cheat, how they manage to do that, how to prevent cheating, and how to deal with cheaters once we find them. And of course, we'll have some time for questions at the end. So if at any point of the presentation, during the presentation, you come up with a question, just write it down so you don't forget about it and you can ask it later. So, first step, why do players cheat? The legendary genius of military strategy, Sun Tzu, said that if you know your enemy and you know yourself, you don't have to worry about the result of 100 battles. So for us to win in this everlasting conflict with cheaters, the first step that we need to do is to understand the psychological motivations behind cheaters' behavior. So why do players cheat? And it turns out that cheaters are humans. So they only care about these three things most of the time. They care about money, they cheat because they want money, they cheat because they want social status, or they cheat because they want to feel powerful. And more specifically, the ones that want money, they feel like they can make a profit off of it. The ones that want social status, they want recognition without the effort. And the ones that want to feel powerful simply like to, win, pretty much. So let's dive a bit more into each of these categories to really understand how they do that. And starting with the money-hungry cheaters, well, when a hacker finds a vulnerable and popular game, they can make profit off of it in two ways. The first one is by making cheats, or exploits, it's the same word. I will use that interchangeably during the talk. And then they sell those exploits to other players, so they make profit off of that. The second way they can make profit off of it is they use these exploits themselves to hoard huge amounts of premium currencies of the game into their accounts, and then they sell these accounts on secondary black markets at a discount. So why do we care about this? We care because they hurt our line of business, because all the money that they get from these activities is money that we do not get as developers. So they are reducing our revenue, and this is, of course, a problem for us. Then we have the second category of cheaters, the one that really crave social status. These are people who want recognition without the effort. And it might seem harmless, but in reality, they devalue the entire ranked experience of a competitive game. So they annoy the honest competitive players and causing a lowering of the retention and engagement, which of course hurts our metrics. So this is the kind of cheaters that we really don't want to have in our game, because every competitive player will just say, oh, this is full of cheaters, I'm not going to play ranked in this game. And then we have the category of cheaters that simply want to feel powerful. These people enjoy crushing their enemies, bend the game rules, and they only want to win, okay, at the expense of everybody else. And the problem is that they make the experience of the game so sad and frustrating for everybody that is unfortunate enough to come across their path to self-realization. So these are the people who actually make other players rage quit your game and leave negative reviews. And once you start getting review bound because you have cheaters on your first day after the launch, it's very, very, very hard to recover from that. So you really need to stop them before they can actually, tamper the sentiment of the game. So a critical point to understand is that only one category of these can appear at any point in time during your game. The other two, and specifically the money-hungry and the social status-hungry cheaters, they only show up if your game is popular enough. So you don't have to worry about them in the early phases of the game, but they become a real problem after the release if you haven't taken the appropriate countermeasures to prevent their cheating behavior. So, and unfortunately, many studios focus on cheating when it's too late. They focus on cheating when they've already released their game and the damage is already done. But at that point, you are no longer doing cheat prevention, you are doing damage control. And again, it's very hard to recover from that if you already have negative reviews on Steam. Because every person that is coming to your Steam page, they're going to see that overwhelmingly negative score, and they're just going to go to the next game. They're not even bothering about understanding why it gets so much negative sentiment. Okay, so when is the right time to focus on cheating? In the green bar, what you can see there. Right before pre-launch, and ideally when you have like a complete game loop. There is one exception, which is about the authority model. We'll talk about this a bit later, which is something that you need to decide at the very beginning of the game. Okay. But in general, don't focus on cheating when it's too late. Try to focus on that when you know your mechanics, you know your economy, you know how things should be done and what is correct behavior and what is incorrect behavior. And then like that is pretty much when you have some game that is already there, you have some little community of people that are playing it, and then you can adjust based on that. But don't do that after launch. That's already too late. Okay, so this is why player cheats. But how they manage to do that? The reality is cheaters do it because we allow them to. We are the ones giving them all the things that they need so they can cheat. And what does a cheater need to cheat? Well, a few things. They simply need access to a copy of our game, or a build, how we call it usually. They need access to secret information that usually they should not have when they are playing the game. They have access to vulnerable code, or to a game that uses the wrong authority model, which kind of ties to vulnerable code. And since I mentioned this already twice, I think it's time to explain what is an authority model in the context of a multiplayer game, because it's a very specific thing for the multiplayer game. So, what is an authority model and why do we need it? Well, in a multiplayer game, somebody needs to make decisions about how the simulation, the shared simulation that is synchronized with all the players, moves forward. That is defined by the authority model. So basically, who decides if a player hits somebody else, who decides if something needs to be spawned, what is the actual health amount of a specific character, NPC, whatever, that is all defined by the authority model. And we mainly have two authority models, the server-authoritative one and the client-authoritative one. There are also variations like distributed authority, we'll see that later in the talk, but these are the two main families that we need to care about when we are talking about cheating, okay? And what is the difference? Well, in a server-authoritative model, you have a centralized server, which is usually a machine, a very powerful machine running in the cloud, okay? And it's running in the cloud of the company. So it's owned by the company or by a service provider that can be trusted, okay? And the thing is that all players connect to the server. Each player is a client, it's called a client, and think of a client like any device. It can be a mobile phone, a PlayStation, a computer, whatever. It can be whatever, okay, that is connected to the server. And the clients only send the inputs to the server. So they do not say, hey, I'm jumping, or hey, I'm hitting somebody. No, they say, I want to jump, I want to move forward, I want to hit somebody, I want to shoot. And then the server makes the decision. The server says, yes, you are not immobilized, you are not stunned, you are not blocked by something, you can jump, you can do whatever you want. Okay. But that's the server that decides that. And then it synchronizes the information with all the other clients. This takes, of course, a bit of time because the information needs to travel. Okay, so we have this bit of latency while the information travels along these dotted lines towards the server and back. But this is secure. This is the model that is the securest model that you can ever have. Okay. Because we have something that can't be tampered with. Nobody can access the server. Cheaters cannot access the servers, physically at least. On the other end, we have the client-authoritative model. Now, the client-authoritative model has a player acting as the server. Okay, so that player has the exact same power as a dedicated server in a server-authoritative model. So they have absolute power. Okay. And since they are also players, they, of course, have a vested interest into cheating, okay? So if you have a client-authoritative model, one of the players is going to have absolute power. They're also going to process their own inputs faster because they are connected to themselves, so there is no, like the information travels to them immediately, okay? And the worst thing is that sometimes if you implement a server-authoritative model in the wrong way, you end up with clients also sending not only inputs, but also state changes. And if a client sends a state change saying, hey, I moved to that position, well, they can teleport, they can do speed hacks, they can do whatever they want, okay? So don't get bamboozled by the fact that you say, I have a server-authoritative model, I'm secure. No, because you need to properly implement that, and you need to be sure that all your code follows that server-authoritative model. So what happens if you pick the wrong model? Again, of course, you have cheating, first of all. That's the main problem. But you also have a terrible user experience in some cases because, as I said, server-authoritative has additional latency. So for some games that are very fast-paced, unless you implement some techniques that allow to reduce that latency, you're going to have some problems with people teleporting or with people rubber banding, moving back and forward, these kind of things. And of course, like, it can make the development more complicated than it needs to be because, for example, if you don't need anti-cheating measures or if you're making a casual game, well, you don't really need to go into server-authoritative stuff and the complexity related to that. So what is the recommended authority model for my game, you could be asking? Well, don't worry, I got you covered. You can reference this little table here, where you can see that they also added the distributed authority column. And think of distributed authority as a hybrid between the two, between server-authoritative and client-authoritative, where basically you have a little server that relays the information, but the simulation is managed by the clients. So every client manages a piece of the simulation. And they collaboratively do that. That's why it's distributed, okay? So what do we use these for? Server-authoritative is the right choice whenever you're making a PvP, so player versus player, competitive game. Or when you are dealing with money. If you are dealing with money, like if you are buying premium currencies or if you are spending premium currencies, unlocking characters, like metagame progression, that is server-authoritative. Like, you need to use server-authoritative because otherwise people can simply fake all of this. They can say, yeah, I earned 1 million coins or whatever, okay, in your game, and then you give them because they're the ones approving their own requests, right? If you use the client-authoritative one. So server-authoritative whenever you need to be sure that things are done in the right way, that players are not cheating. That's it. Of course, it's costlier and harder to maintain because you need dedicated servers, you need to connect to them, you need like additional code to deal with the latency and so on. But that is it. That is the choice for this. And the advantage of server authoritative is also that it usually provides a pretty good user experience if you do it right, because the server is a powerful machine, so it can process all the information very fast. On the other end, we have client authoritative games. Client authoritative are perfectly fine for whatever is cooperative, okay? Like if you're making repo, for example, or Peak, or this kind of games, like you don't really need a server authoritative gameplay. So for whatever is casual, client authoritative is fine, and it's not safe to handle money at all. Forget about that. But it's cheaper, of course, to maintain. Also because basically players are giving them their hardware as a server, which is good on a cost perspective, but is also bad on a user experience perspective, because if the host, like the player that acts as the server, is somebody who has like a potato machine, then everybody's going to be running the simulation based on that potato machine, which is bad, of course. And then we got the distributed authority, which is kind of a middle ground, and it's basically useful if you're making a social hub experience like Roblox, Minecraft, or whatever. So in the context of anti-cheating, just forget about that. All right. It's now time to become our enemies. We now know what the cheaters need to do what they want, but how they do that in practice? Well, mainly in two ways. The first one is through local cheats. Local cheats are a special type of cheats that only leverage information that is already available to the client. So when you are making a local cheat, you are not really sending data around, you're not trying to tamper with the other player's experience, but instead you're giving yourself unfair advantage by leveraging the information that is already on your machine. For example, wall hacks, you can see in the screenshot there. Cheats that allow you to see enemies through walls. If you know the position of the enemies, it's easy to implement that stuff. It's very easy to implement that stuff. Or like cheats that allow you to see in the fog of war. Imagine if you're playing League of Legends and you can see in the fog of war as if there was a ward there. Or in a card game, for example, we have peeking cheats, which pertain to the same category, where you can see the cards that are in the opponent's hand or like the cards that you're going to draw. All these types of cheats are local cheats. And we also have the aimbots that fall into the same category, like the cheats that allow to move your cursor automatically to the most vulnerable parts of the opponents when you're, like, for example, attacking them or shooting at them. So the problem with this is that they are very hard to detect, because they leave no traces around. Like, they do not send any data. Again, they just read what is in the memory of the computer, we'll see that, and they act on that. So it's very hard to detect them. On the other hand, we have the state-changing cheats, and these are the most dangerous one. Like, if you have those in your game, you are cooked. It's done. Because state-changing cheats affect everybody in the game. They can make somebody invincible, they can make a team automatically win the game, they can automatically one-shot everyone. Like, these are the most powerful category of cheats. And the thing is that you can prevent those. You really can prevent those. All you need is a server-authoritative environment. And we'll see that. So, how can these cheats be implemented in practice? Well, one way is to by hacking the memory, the RAM of the computer. Okay, so the RAM is like this super long list of addresses in the memory of the computer where information is stored. All the information about the game that you're running is in the RAM, so it's there. Okay. So what players can do, well, what cheaters can do, they can access this information, they can read that because it's on their machine, right? And so they, for example, they can try to find the number in the memory that represents the health or the amount of ammo that you have in your weapon. They can go there and they can change that from, I don't know, 30 to 100. And now they have 100 ammos in their weapon. Well, that works. That works, of course, if it's a client authoritative game. Because if it's a server authoritative game, you can change that on your computer, but the server, which is the one that makes all the decisions, has the correct value. So it just ignores that. And so, like, we need to be very careful about this. Another way to implement those types of cheats is by hacking the build. So now think of a build as the executable. Okay, it's the copy of the game that you download on your machine. Okay, and that build is a sequence of zeros and ones that the computer can interpret. Now, the thing is, once a build is in the hands of players, they can do whatever they want with it, including reverse engineer that sequence of zeros and ones to go back to the original code. Yes, there is software that allows you to do that, and that's an example. It's called ILSpy. So once a cheater has access to your build, they can try to, like a child trying to understand how it works, they can try to break it, to open that and see, oh, what's in here? How does this work, right? And so they can try to then change some of the game code. How? Well, they can do something that is called code patching. Code patching is an exploit, okay, and it consists in making minimal changes to the existing logic of a build, okay, to produce the results that we always want to produce. In this example, okay, we start with some code, like you write that code, like set power into power in your code, okay, that is your code. You make the build, which is a sequence of zeros and ones, but then the hacker looks at that build, uses some kind of software, and it goes back to this code that you can see here. And once they have this code, which is the equivalent of that, but a bit more complicated to read, they can simply change a part of it. You can see the part in red. They change that part, and now they recompile the game, and they end up with that code that you see there. So they are always assigning 100 as the power. So even if your original code assigned some random value, depending on the situation of the game, now they always have the maximum power. So this removes even the need of having to scan the memory and find the information there, because they can simply change how the code works. They can simply change how the game works, which is also why, like, it's not really useful to focus on anti-cheating for single-player games, because, like, once an hacker has access to the build on their machine and the memory, they can do whatever they want with it. You can't really do much about that. So now we know how cheaters can cheat, but how do we fight back? Well, in reality, we don't. Or better, we fight back by avoiding the battle. Because this is a cat and mouse game. So the thing is, whenever you find a fix for an exploit, the hacking community will come back with some other exploit. Like, they will always find a way out. So it's a matter of who gets tired first. Okay. And you have your studio, so you are limited by the power of your studio, but your enemy is much, much, much bigger than you. So you cannot fight them directly. You have to fight them by discouraging them. You have to make it so hard for them to try that they get bored about that and say, no, I'm not going to hack this game. I'm just going to focus on some other game. But keep in mind that if the rewards are high enough, people will still try to do that. So that's important. That's something you need to keep in mind. One way to discourage the enemy is by making their life harder by making a server-authoritative game, which gives you like that initial layer of protection, and minimizing the information that you send to the clients. Okay, like you don't need to tell them where the enemies are if they are not able to see them yet. But we can also do something more practical, right? We can also do some actual protections to the code, for example. Okay, we can use code obfuscation. That is one technique. So code obfuscation is a pretty simple technique that takes your original code, before compiling it, takes your original code and changes it to some unreadable gibberish that nobody is able to understand. So the same, like the code still works. Like that makes no difference for the computer. Like the machine is still able to interpret that properly, okay? But for a person reading that, good luck figuring out what it does. So code obfuscation is able to at least protect your code from the curious people that are peeking at it. But the problem with it is that it breaks all the reflection-based code. And reflection-based code is all the code that identifies other code by its name. So if you have some code that says, oh, I want to go to the set power method and do something, well, if the set power method is now called that stuff, it's going to break. And this is usually the case for many netcode frameworks, unfortunately. So especially, for example, when you add RPCs or network variables, these kind of things, they usually use reflection before the compilation. So this can, unfortunately, be very risky to implement in a mature code base, especially if you're making different releases, like one for the server and one for the client, and you are then making different builds, and you're obfuscating in different ways all the time. So yeah, that could be problematic. But I just want you to know about that, because it could still be useful. The real way to protect your game is to never trust the client, ever. Like, that's the only way, because if you trust the client, you're allowing state-changing cheats, because the clients can send that they are doing something, and they don't have to ask your permission at that point. They're just saying, I did this. But no, you want them to ask permission. So this is the golden rule. It doesn't matter how secure you think your game is. Always think that assume that the client is just trying to cheat, okay? So you need to run state-changing code, server-authoritatively, okay, through your server. And specifically, whenever a client sends an input, you validate that. Like, don't assume that, even if you're just sending the input, don't assume that the input is valid. Always check, can this person move? Can this player do that? Okay, before they actually do it. Okay. So the server validates the inputs, makes a decision, and relays them. It's not the client. Client only sends the inputs. Another way to protect your game is to isolate the server and client codes into different assemblies. This is very easy to do in Unity, because you can simply define all the code that goes in the server build, all the code that goes in the client build. And so if your client doesn't need any of the server code, well, don't put it into it, right? Because otherwise you're letting people have a look at it. And you don't want that. You really don't want that. So using separate assemblies can help you, making it harder for cheaters to understand how the server reasons when it's validating an action. Okay. And another way to protect your game is to encrypt the transmission between the client and the server, because even when you're making a secure game, there is still an attack that is possible to do. It's called man in the middle, where basically the hacker introduces themselves in the connection between the client and the server. So it forces a disconnection and then makes the client connect to them and relays all the information that it gets to the server. This might seem harmless, but first, it increases latency, and second, it allows the hacker to edit all the information that it receives from the client and from the server. And so the hacker can now exploit that to introduce malicious links, malicious information, to try to steal your credentials, to analyze the information that you're sending. So this usually doesn't happen a lot in games, but just so you know, this is possible, and the solution is pretty simple. You just need to enable the encryption at the transport layer of your netcode framework. This is, for example, is super easy to do in Unity Transport if you're using netcode for game objects. So yeah, it's just a checkbox, enable that. It's pretty easy. There is a little bit of code to write, but still. And then, last but not least, actually very, very important, and what is one of the most common attack vectors is secrets. Don't store secrets in your build or version control. And what is a secret? Well, for those who don't know, secrets are basically passwords that a web service uses, or an API uses, to recognize your specific project. So whenever, let's say, you're generating an image, okay, with some kind of API, well, you need to send them you need to send them your secret, okay? And then they make you pay for that image. They make you pay for that request because they know that you are using the service, okay? So the problem with secrets is that if you add them to your code, like many people unfortunately do, hackers can read them. They can open your build, they can reverse engineer your build, and they can read the secrets. They can read that stuff, okay? And once they read that stuff, they can use it because there's nothing stopping them from copy-pasting this in their project and saying, yeah, I want an image, and yes, I'm definitely some legit project that has a subscription with you, so just make me pay. I'll be super happy to do that. But you're the ones paying. And that is an issue because they can really, and I'm not joking, they can bankrupt you in hours. If they have a popular enough application that leverages your secrets, they can bankrupt you. And then it's going to be more complicated to go to the provider and say, yeah, that wasn't really me, and you need to provide proof, and it's going to be something that you don't want to go through. So what is important is not only you don't have to, you must avoid including the secrets in your build, you must also avoid including them in GitHub and version control in general, GitHub, GitLab, whatever, Bitbucket, whatever you use. Because leaks happen all the time on these platforms. And if somebody downloads your project and finds a secret into that, you can be 200% sure that they will post it somewhere for everybody to use. So never push your credentials or your secrets into version control. That is not safe. What is safe? Because that could be one question. How do I do this then? Well, there is some software that is called Secrets Manager, okay? This is a special category of software that you can use, and usually these providers will give you a way to store the credentials in a safe way and to access them. If you don't know any, just so you know, there is one in Unity Gaming Services that is called Secret Manager. It does exactly and only that. And even if you don't want to use that, there is Unity Cloud Save or whatever database that you can have that it's secure, and you can simply retrieve this information from there, okay? So that is one way. Another way is to have a local file in the build that you not in the build, like on the server, okay? And you use that local file to store the secrets. And that local file is it's outside of version control. You never ever push that, okay? So how do we manage this? So what if we need to, for example, generate an image from our client, okay? So we need to talk with the API. We need somehow to send a secret there, right? So in that case, what we can do is we create a server-authoritative intermediate, like we create a cloud function on Azure, Unity Cloud Code, whatever you want. And the client sends a request to the cloud function without any secret. Then the cloud function, which is on our servers, it's running in a secure environment and so on, they have the secret. They retrieve the secret from our systems. It could be a local file, it could be the command line, it could be a secret manager, and they make the request on behalf of the client. So the cloud function interacts with the server replies, and then the cloud function replies to the client. That's it. That's how it works. So you don't have the client directly talk with the API. You have an intermediate layer there that you make that is server authoritative, and it's under your control. Okay, so what about local cheats? Because so far we've looked about state-changing ones and these kind of security issues. The problem with local cheats, as I said, is that they are very hard to detect because they are based on information that is already available to the client. So the problem with this is that, actually, what you can do about this is you can look for patterns, okay? Or you can use some kind of local anti-cheating software. Like you can see if a player is clicking always the same pixel on the screen when they are pressing a button. Like this kind of hint gives you information about if player is using a bot or something like that. So, but the best you can do is guessing, okay? Because you cannot be certain about that unless you watch like a recording of the game from the player's perspective. So this is very hard to do, and it's mostly guesswork, so you can have a lot of false positives. So that's why the best way here to fight back with local cheats is to prevent them. So for example, in a card game like that is Ariokan, a game I'm working on. It's a card game. In a card game like that, you only need to know about your cards, the ones at the bottom. But to render the UI and the state of the game, for example, for the opponent, you don't need to know what cards they have in their hand. You just need to know that they have, 5 cards. Okay? And then you draw 5 cards in the UI. So it's all about reducing the information that a player doesn't need to know to render the UI and the state of the game. That's how you fight with local cheats. And also, you can cap like the daily rewards that you can obtain, because a problem with local cheats is that a player can simply automate some actions. Like they can automate that they join a game and they surrender and they still get some currency. So they can do that infinitely if you don't cap the rewards. But if you cap them, then they can you limit the damage, right? You limit the damage and you improve the user experience. And you can also compile the game with IL to CPP, which provides an additional layer of protection, because the code goes from being the C# to C++ and from C++ to the actually binary. And that makes it harder to reverse engineer your code, because then the hackers have to deal with assembly, not with C# when they are reverse engineering. So that is way better from that perspective. And last but not least, we can protect the memory. We can protect the RAM. How do we protect the RAM? Well, we have two ways of doing that. And before we go into that, I just want to give you like a clearer understanding of how the RAM works. So it's basically a long list of addresses, okay, next to each other. And a value can be stored across multiple addresses, depending on how big the variable that contains the variable is. So you can see, for example, that int are 4 bytes, booleans are 1, and blah, blah, blah. So they take different space in the memory. Now, this is very important because that determines where a variable is starting, so where the box is in the memory, okay? And when we do memory scrambling, which is a pretty easy way to protect our memory, what we are doing is messing with the layout of the memory. We are messing with the order of the boxes, the variables in the memory. So memory scrambling consists of adding variables in the middle or at the beginning of a list of variables. So you change the address of everything when the game starts, pretty much. So you can see here, before the scrambling, the ammo variable starts at the beginning of the gun class. So if the gun class is at that address, the ammo variable will always be at the very beginning of it, and the max ammo will be 4 bytes after that. But if you add something before those, well, then now you are offsetting everything, like everything has moved. So when the hacker goes there with this cheating software and goes like, yeah, I want to go to that memory location because I know that the ammo is always there, they are now reading something else. And they are not able to do whatever they were able to do before. So this is, of course, a temporary solution. It's free and like it has zero risk to do that for us developers, but like for the hacker, it's just a way to, oh wow, all my cheat tables, which are the references to these addresses, are now broken. I need to recalculate them. And some hackers might say, yeah, I want to do that because I really care. And some others might say, I'll let it go. And they move on to the next game. Another way to protect our memory is to use projection. So usually what a hacker does is they search for a specific value in the memory. Let's say you have 100 HP and you want to bring that to 150 or 200. Okay, so you start searching for all the memory addresses that have the number 100 into that. And so when they find that, they can change it, they can change it to 150. But that only works if you're actually storing 100 in memory. What if you store some random value that is not 100, but that can get to 100 through some logic? That is the concept of projection. So instead of storing the actual value, you store that value plus 2, or minus 2, or whatever. You decide. And the thing is that the hacker can only scan for the value that is stored, but not for the value that comes out of some logic. Okay? Because this is not in the memory. The real value is not in the memory. So you calculate that at runtime. So this is a pretty safe way as well to protect your information in the game and make the hacker very confused when they are searching for that 100 in memory. They can only find other stuff that is not 100. Okay. Now, if you want to make it even harder for a hacker to cheat in your game, there are more advanced techniques, like you can try to measure the time between instructions, you can run the game in a virtual machine, but all these techniques are way more complex to implement and have the unfortunate side effect of either breaking your game, if they are deep enough, or to actually flag your game as a virus. So that's not really good for your brand's reputation in the hands of players. Like, players can have a lot of problems with this. So it's better that you apply those only if you really, really need them. There are also some anti-cheating libraries that you can use, both on the client side and on the server side. The problem with those is that on the client side, they are very CPU intensive. So players usually don't really like that because they start your game and they like their CPU goes to 99%, they're like, oh, this game is so unoptimized, blah, blah, blah. And they start crying about that. And they can also be bypassed, pretty much, by very skilled hackers. They still offer some kind of layer of protection, but they can still be bypassed. And then you have server-side anti-cheats that are usually a bit more expensive, but they are very good, for example, at providing insights for local cheats, because you can see that a player, for example, is shooting at somebody that is not in their line of sight, and you can get pretty good reconstructions of what happened during a match with that. So you can track very, very complex behavior there. But they are also complex to implement. So it's all a matter of how much you're willing to invest from a time and development perspective into this cat and mouse game. And now, a little secret. Did you know that pricing is also an anti-cheat? Because pricing is a barrier to your game. It is a barrier that keeps normal players out, because they have to pay for your game, of course. But it's also a barrier for cheaters. And it's a pretty effective one, because if you think about it, now cheaters have to pay every time they need to make a new account. So unless they are super good at what they do and can hack your game without being detected, every time they attempt to do that, they have to, and every time they get caught, they have to pay again. And that is a huge disincentive for people who want to make money off your game. It's a very huge disincentive. So the higher the cost of a hacker or a cheater to access your game, to be able to try hacking that, because there's no guarantee that they will manage to do it, then the less cheaters you will have. And every time they get caught, they have to pay you again. So you get paid for them to try, which is a great thing. So let's say that you did all of this, but you still find a cheater at some point. What do you do with them? Well, your first instinct might be to take your ban hammer and smash them with that. But nope, you need to hold your ban hammer. Why do you need to hold your ban hammer? Well, because if you ban a cheater immediately, right after they start cheating, they can figure out how you figured out that they were cheating. So they can understand, oh, I did this, and they immediately found me. So I need to do that in a different way next time. So it's counterproductive to ban a cheater immediately. It's better if you wait a bit and you ban them later, because in that way, they can be super confused about that. They will not know anything. So publish them after a few hours. Never tell them how you found out. Never. Because, again, you're discussing security here. You don't want to reveal your secrets to them, because otherwise they will use that information to mess up with you. It's also good to let your community know that you are banning cheaters if you are actively doing that, because people like when you are cleaning up all the garbage from the community. And then remember to be merciless. The higher the punishment, the higher the lower the chance that somebody will actually go into that. Because if it takes time for a player to build, progression in your game, like if it takes them days, maybe money, and so on, the thought of being banned permanently can be very scary. So this helps you keeping your community clean, especially with veteran players at some point. All right. We got to the wrap-up part. So remember, cheaters cheat because we allow them to. This is a cat and mouse game, so you need to decide if you really want to invest into that, and just know that whenever you fix something, something else will appear. But like the solution to this is to raise barriers, like to discourage the enemy. You want to tell them, hey, this is too hard to hack. Don't waste your time here. Go to some other free-to-play game that is there. They're free. You can make 20 accounts and try, right? So you really need to discourage them. You need to implement these discouraging measures and cheat prevention at the right time. Otherwise, you're wasting speed, or it's already too late if you're after release. And then be merciless, okay? Hold that ban hammer, but when it strikes hard. All right. Thank you so much for being with me here today.